hope you're doing fine enjoying my videos. And if you've seen the question which I've posted in the previous video, I finally brought the solution for that. You can check the video. The link is in the description below. So here we have the diagram of that question. We basically have a triangle, and we're supposed to find the angles. And then this is the altitude. And then this is the midpoint, and this is the midpoint. So we're basically drawing a circle. Well, N is basically the point where the circumcircle of MCD meets 80. Then you join these two lines, and then you get X, and then you take the circumcircles of MXC and NXD. And then the second intersection point of these two circles is Y. Then you just extend them to get C. And now G is the centroid of the triangle, and we have to prove that if this is a right angle, we basically have to find the angles of the triangle. And this is the condition given for this. So the solution is very long. I was too lazy to type it, so I just wrote it and took photos. So here we have CMND is cyclic, obviously, from the definition. So from power of a point, we have AN 80. This into this will be equal to this into this. So we have this. So A has equal power with respect to both circles, MXC and NXD, which makes it lie on the radical axis of these two circles. So it will have to lie on the common chord of those circles, and the common chord happens to be XY, so we know that AXY is collinear, which means AXYZ all lie on the same line. And AYD is equal to XYD, obviously, because they're on the same line. And then this is 180 minus X and D because this is a cyclic quadrilateral. And then 80 is the altitude and MD is the median. Because for a right angle triangle, the median will be equal to half the hypotenuse. So that means MD is equal to MC. And then we have these angles, and we just solve for CND and CMD. And now we get XND, which is basically this angle, which is basically CND. And then we get XYD is equal to 2C. That is because AYD is equal to XYD, and XYD will just be equal to 180 minus XND because this is a cyclic quadrilateral. So you get AYD is 2C, and then you solve for AMD, which is basically the exterior angle. So this is angle C, this is also angle C because it's isosceles, and then this is 2C, exterior angle. And so that's how you prove that, because from the same line, it's subtending the same angle. AYD is equal to AMD. So these first points have to lie on the same circle, so they're concyclic. So that's how you prove this, and then you basically do the same thing to get A and YC is cyclic. Now we assume variables. This is interesting, but equation grinding part of this question. So XY is X and YZ is, sorry, XY is Y, YZ is Z, and we're assuming AX is X. Although it's not drawn in the figure, but that's what it is. And we're taking BEC is A, CA is B, AB is C, as usual, and DAZ is theta. We're assuming it as a variable, so that will be easier. And then from power of a point, we have X. AX into AY, which is basically X plus Y, will be equal to AM into AC, which is basically just B by 2 into B, which is B squared by 2. And then the calculations basically start. You have B sine C, which is basically the altitude, divided by cos theta will give you this entire length, and that's just X plus Y plus Z, which is written here. And then from that, we borrow the value of x plus y from here, and then we take it here, and then that gives you z in terms of x and b. And then we use sine rule in a and x. A and x is basically this. Then we get something like a and x. And x by sine theta is equal to an by sine 180 minus 2c minus theta. And 180 minus sine 180 minus x will just be sine x. So that's what's been used here. And then from this, we find nx by using sine rule in this triangle. We just find the angles of this. It's very easy because this is c, so you know this angle. You know this angle because it's equal to this angle, and then you basically find this angle, and then that gives you all the ratios, and therefore you'll get the side lengths in terms of known variables. So that's what gives you the value of. So basically just keep writing equations like that. It's kind of annoying, but well, that's how you do it, I guess. So here we're just using the fact that this is just 90 minus c, and this is just 180 minus 2c. So that gives you this angle as 3c minus 90. And then we use that, and then we use sine 3c formula, actually cos 3c formula, because it evaluates to minus cos 3c. And then we use minus cos 2, or basically cos 2c formula. And then, yeah, this is just compound angles. So now we just evaluate it to find what theta is. And here we just take sine 2c, sine of 2c plus theta this side, and this thing this side. So now we have something like, this is sine 2c into cos theta plus cos 2c into sine theta. That's basically how you expand sine of a plus b. And then divided by sine theta, the sine theta from, well, cos 2c plus cos 2c into sine theta cancels out with this, becomes cos 2c, and sine 2c into cos theta becomes sine 2c cot theta, as you can see here. And cos 2c is just evaluated like this, because that's how you get cos 2c. And then we just evaluate this. We write it as, well, we try to pull out an integer out of this fraction so that we can cancel out stuff, and then we get this. And then 2 sine square c goes that way, and then we expand sine 2c, and then we cancel sine c, and then that should give you the value of cot theta. And then once you're given cot theta, you can find cos theta and sine theta. It's pretty easy using this. And it's like some 10th grade CBSE, or it's like some average 10th grade question. Express cos theta in terms of cot theta. Nx by sine theta, we basically use the equations we had for nx before. Nx by sine theta is equal to x by sine 2c. So we use that to get the value of x, which evaluates to be something like this. It's pretty annoying, but it looks not that hard. And now we just plug it in this formula, because this is what we had before, x and x plus y, so that's how you find y. And then that eventually gives you the value of z. And here I just use dot 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 just to say this same thing, because obviously it won't change. So this just means root of 8 sine power 4c minus 5 sine square c plus 1. So that's how this evaluates. And then we just get the value of z from the way I mentioned, and then that gives you this for z, b into 2 sine square c minus 1 whole square by 2 sine square c root this, and then this is y. So as you can see, 2 sine square c minus 1 cancels, and then you have 2 which cancels out, and then b obviously cancels out, and then the root thing cancels out. So you're left with sine square c by 4 sine square c minus 1 into 2 sine square c minus 1. This is a nice and easy quadratic. And fortunately for the question, notice that AD squared by CD squared is just, AD squared by CA squared is just sine square c. So the sine square c over there cancels out. So this is gone. And now we just have this thing being equal to 1. And then after evaluating it, we'll just get sine square c is 3 by 4. And you know which angle has sine square c equal to 3 by 4? It's 60 degrees because sine 60 is root 3 by 2. And now we have GZ's perpendicular to AB. This is another set of grindy equations. So you just have to drop a perpendicular and then find this distance in terms of the sides. And then ZC will also be easy to find. It's just DZ, which is 80 into tan theta. Well, CD minus 80 tan theta. So that'll give you ZC. And obviously we get GZB as 90 minus B. So now it's almost over. All we have to do is use coordinate geometry a bit. Well, the centroid will just be the average of the x coordinates and the average of the y coordinates. So we're basically just taking the coordinates from C, but we're just assuming this direction is positive for simplicity. So basically this way is positive and this is the origin. So that will just give you, from coordinate geometry, b sine c by 3, and then kz is just, k is the perpendicular from G to BC. So kz will just be kd plus dz, right? This is k, suppose, drop a perpendicular, and then you add kd, which is basically just, well, this distance minus this distance, and then you add cd, which you can get which is just 80 tan theta, and then you just substitute tan theta, 80 and everything, and then yeah, it all simplifies into, well, you just have to use the projectile or the projection formula, which basically says that A is just B cos C plus C cos B, which is obvious because this is C cos B and this is B cos C. And lastly, we have the evaluation, which gives us tan B is equal to cot B, and this angle is none other than 45 degrees. So our triangle is just B is 45, C is 60, so A is 180 minus 45 minus 60, which is 75. So our triangle is a 75, 45, 60 degree triangle. So that's the answer. So I hope you enjoyed my video. Thanks for watching. Do share this video and subscribe for more such content. See you again in the next video. Bye bye.